Okay, so now what happens if I want to go, I've already gone mixed to entire. So now I want to go entire to mixed. How do I go backwards? And this one's a little bit more complicated, but it will be okay as long as you know your perfect squares and perfect cubes and those things, okay? So imagine, just for example's sake, that I have, and we'll start with the cube root, and let's say I have the cube root of 81x to the 3, okay? And I want to make that entire radical a mixed radical. So what do I do? So the first step, and again I'll type these out, is we try to find a factor of the constant term that is a base raised to the index of the radical. Okay, now you might say, what are you talking about? So let's see what we're talking about in terms of this particular question. We're looking at, I want to see if I can write 81, a factor of 81, as something cubed, because I want it as a base raised to the index of the radical, raised to that. So I want to write 81 as something times something cubed. Okay, and this is where your knowledge of perfect cubes comes in. Your perfect cubes are 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, and that's the one I'm going to use. Okay, so I'm going to write this as 3 times 3 cubed. That's what I'm going to try to do. The reason we're going to do that I'll explain in just a second, but we want to try to get a perfect cube. Okay, so the factor of the constant part of the term. Then we look at the variables, and what we do with the variables is we're going to take the power of the variable and divide it by the index. If it doesn't divide evenly, we split the variable into a factor that does and the remainder. Okay, so we're going to look at our x cubed. Up here, and we're going to say x cubed. We're going to take the power, there's the power, 3, and I'm going to divide it by 3, and it gives me 1. So that works nicely. So I'm going to say, okay, then when I divide it by 3, it becomes x to the 1. All right. Again, why am I doing that? Here's why. So here's my example. Okay. Well, actually, the third step is to then remove that by actually taking the cube root. So what we're going to do in step 3 is we're going to remove the perfect cube, or we'll say the base, and the variable, sorry, the part of the variable, I can type here, that is divisible by the index. Okay. And again, this is a little bit wordy and a little bit confusing until you see an example or two, and then hopefully it will make a little more sense. So we're going to take out, in our example, we started out with this. We started out with the cube root of 81x to the 3. What we discovered was that we could write 81 as 3 times 3 cubed, okay, and then we could write x cubed, it divides by 3. So I take this part, okay, the perfect cube, the base part of the variable, the base, sorry, so we take out the 3, we actually take the cube root of 3, so that gives me 3, and I actually divide this out. So the part of the variable that was divisible by the index, which is the whole thing, comes out, and I actually divide it by the index, so I end up with x to the 1. And what's left underneath is 3. And so I've written this entire radical as a mixed radical. Okay, that's the process. Now that process is a little bit confusing until you try it a few times. So let's do another example. Okay, and again, we'll go back to your textbook for this so that we can follow. It says the square root of 200 is the first one. And I'm just on the next page of the textbook than I was in the previous video. So I'm on page 275, I believe. But if you look at the square root of 200, I'm now looking, what's the index? So the index is, it's not written there, so it's a 2. So I'm looking for a perfect square now. I'm looking for something squared that is, and the biggest one that I can find, that is 200. So if I go 200 is 2 times 100, and 100 can be written as 10 squared. So I can write a factor, there's a perfect square factor of 200. So I write it like that. I go 2 times 10 squared. And then there's no variable, so I don't have to look at that second step of splitting the variable out. So then I look and say, okay, well 10 squared, the square root of 10 squared becomes 10. So I write the base without the power now, and what's left inside is a 2. Okay, so following the steps, step 1, I found a perfect square factor because it was the index was a 2. So I found a factor of 200 that I could write as a base to the power of 2. I then wrote it that way and then took the square root of 10 squared, essentially canceling the power. 2 divided by 2 is 1, and leaving the base there out front. Okay. The second example, we jump back to where our textbook is the 4th root of c to the 9. So we have example A here. Example B is the 4th root of c to the 9. So I look at that and I say, okay, I need to figure out, first of all, c to the 9 divided by 4. I say, well, 9 is not divisible by 4. So what I do is I split it. I split it into 8 divided by 4, because that is divisible by 4, and then a 1. Okay, so I split the 9 into 8 and 1. That's divisible by 4, and gives me the ability to then take the 4th root of it. So can't see that very well, so let me just rewrite this a little bit better. I'm trying to split my variable into, see if I can write this a little bigger, c to the 9 is equal to c to the 8 multiplied by c to the 1. So I write it that way. And I'm not going to write the c to the 1 anymore because I don't need to. But then I divide the 8 by 4. Okay, and I get 2. So that comes out. 8 divided by 4 is 2. That's where that came from. And then c. All right. So that's how I do that one. Check our time here. Then we got the square root of 48y to the 5. So again, I'm first of all looking at the number. So I'm looking at 48, and I'm saying, can I write that as a perfect square factor? So you want the biggest one that you can. You know your perfect squares are 1, and then 4, and then 9, and then 16. And I recognize, hey, 16 goes into 48. So I'm going to write that as 3 times 4 squared. Okay, so I've dealt with the number. Then I'm going to look at the variable. 5 is not divisible by 2. Right? Again, the index of this radical, even though it's not written there, is a 2. So I want to split it into something that is divisible by 2, and then whatever's left over. So 4 is divisible by 2, so I'm going to split it into 4 and 1. And that then leaves me with this. I'm going to write the square root. 48, I'm going to write 3 and 4 squared. And then the y, I'm going to write y to the 4th and y. And then I'm going to take this part. Okay, I'm going to take the base of this, so the square root of 4 squared is 4, and I'm going to divide this power by the index, so 4 divided by 2 is 2, so I get 4y squared, and then the stuff that's left inside is the 3 and the y. And there's my mixed radical. All right, so that's how you convert an entire radical to a mixed radical. And there are some other questions if you look in your textbook. Go down. There's some your turn questions there. Whoops. Scroll back up just slightly so we can see them. There they are. So you can try those 3 on your own, and there are obviously more to practice with in the textbook. But we'll leave it there in terms of mixed radicals. That's how you go from entire to mixed. So you've got mixed to entire. It's the first video. Now you've got entire to mixed.